Hello class. Today we are going to discuss a part of suspension that is in continuation with the previous videos, interfacial properties of the solid. So the solid which is present as a dispersed system in the suspension will have an interfacial properties, so that we are going to discuss in this video. So the formulator or the pharmacist who is preparing the suspension has to consider one and for most important point is that whenever he is preparing the suspension should not get sediment. That is, the solid particles which is present in the suspension should not get sediment, should not take sedimentation. That is, settling of the solid particles should not take place. That we will say an acceptable or an excellent suspension. But achieving that is quite a risky process. Means we says that if we have to reduce the sedimentation, thereby we have to reduce the particle size so that we can prevent the sedimentation. So how we can reduce the particle size? We have to reduce the particle size by size reduction to approximately to the size of 5 micrometer. If the particle size is 5 micrometer, it will have a Brownian moment. Yeah, Brownian motion we will say. In simplest form, if I had to say what is Brownian motion means, if the particle size on and above or below the 5 micrometer, it will be random motion in the container or in the system, and mainly it will work against a gravitational force, thereby we are preventing the sedimentation. So how we can achieve reducing the particle size? By doing the size reduction. So the doing size reduction, what will be the other factors which will affect on the solid which is present in the suspension can be well explained by taking the equation into consideration. W is equals to delta G is equals to gamma SL delta A. So what is W? W is nothing but the work done or the size reduction which we are doing to the solid particles which is present in the suspension. Delta G is the surface increase in the surface free energy after doing the size reduction. Then gamma SL. Gamma is the sign which we are using to depict surface or interfacial tension. Here we are telling interfacial tension exists between the solid particles which is present in the suspension and the liquid medium. Then the delta A. Delta A is nothing but the surface free area. So if we are doing the size reduction to the solid particles, these are the factors or the parameters will get affected. That is surface free energy, interfacial tension and surface free area. So if there is an increase in surface free energy, thereby automatically surface free area also get increased. Thereby the system will become thermodynamically unstable. So the system will become thermodynamically unstable. To bring out the stable form of suspension, we have to consider certain points. So what are those? How we can achieve this? We will consider in this equation. So here what the main part or main significant factor is surface free energy. Surface free energy, that is delta G. If delta G is equals to gamma SL and delta A. So if we are increasing or decreasing the delta G, that is surface free energy, thereby we are increasing or decreasing the gamma SL and delta A. So one can achieve a stable suspension by considering the factor delta G. How we can increase or decrease the delta G? We had to consider 2 points, that is, one is delta A and the other one is gamma SL. So here delta A, if we are reducing the delta A surface free area, thereby we are reducing the surface free energy. But what will happen if we reduces the surface area and surface free energy? The particles will come close together and thereby it will forms floccules. Thereby it will form floccules. Again, if the floccules will floccules will form, it will promotes the sedimentation, which is again an undesirable property. So here, how even though we are decreasing the surface free area, we are decreasing the surface free energy, but floccules will forming and sedimentation is taking place. So one has to keep a balance. One has to keep a balance between the particle size and the surface free area or the formation of the sedimentation. So here how we can achieve, that is reduction in the surface free area and reduction in the surface free energy. Even though floccules will happen, sedimentation won't take place. This can be achieved by considering 3 points. 1 point by the addition of charges. By the addition of charges onto the solid particles which is present in the suspension, we can avoid or we can keep the balance between the particle size and the sedimentation. Second, by considering zeta potential. By considering zeta potential of the suspension. And the third one is by considering the distance, interparticle distance. By considering interparticle distance between the solid particles which is present in the suspension and their effect on the potential energy barrier. So now we will see how we can achieve by the addition of charges, by the addition of zeta potential and the interparticle distance. This I will explain by taking one graph. We will plot a y-axis which depicts the interparticle energy. This is interparticle energy, and this x-axis, this is y-axis, and this is x-axis. X-axis depicts the interparticle distance. And this is positive, this is negative. So first point I had told, by the addition of charges onto the particle we can achieve. So how means by the addition of electrolytes, or by the addition of polymers to the suspension, we can provide the charges, thereby promoting the electrical double layer to the system. This I will explain again by taking example. Say for example, you have a suspension which is positively charged. All the particles which is present in the suspension is cations. Now I am adding electrolyte, that is sodium chloride. I am adding. So once I am adding the sodium chloride, it have both positive and negative. So the negative charge, that is anion, will get attracted by the cations, thereby forming the floccules. Okay, and again here the positive ions, that is cation sodium which is present, is get attracted to this negative ion which is chloride. So here what happens, one layer of positive charges will take place, one layer of negative charges will take place, and again a positive charge will take place. So by this, if we are bringing out the flocculation, whatever the floccules which is formed by the addition of electrolytes will be fluffy in nature. Means fluffy in nature. Even the sedimentation will take place. It doesn't forms the hard cake, and it is very easy to redisperse. So this can be this mechanism can be given to the flocculated suspension, addition of electrolytes. Then I had told zeta potential and interparticle distance. So this again I will explain by taking example. Say there are two types of forces exist between the particles. One we will call it as a adhesive force and other we will call it as a cohesive force. Adhesive force is between the positive and dissimilar charges of the particle or dissimilar particles, whereas cohesive force is between the similar charge of the particles. So if the particles are interparticle distance, if the particles are separated by, what will happen, separated by too far distance, or if the particles are come close together, what will happen? Now we will see. So if the particles, this cohesive force or repulsive force, which is here in interparticle energy, I will designate it by positive charge, that is repulsive. Similar particles will get, and this is the curve. This is repulsive curve and the energy, repulsive energy. If the dissimilar particles are present which will come close together, this I will exhibit by here, which we will call it as attractive force and repulsive force. This is repulsive force and this is attractive force, and the curve is this. This is attractive force, or I will designate it as a VA, and this I will designate as VR. Okay, so this is repulsive force and this is attractive force. And there is one more I had told, interparticle distance and the effect of interparticle distance on the potential energy barrier. The potential energy barrier, we will say this one. So what is this potential energy barrier? It is total energy, VT. Total energy is equals to VA plus VR. That is, total energy is equals to attractive force energy plus repulsive force energy. And this region which is there is called as controlled flocculation force, or a flocculated suspension, which we will get by the addition of electrolytes. So to have a very good suspension, the potential energy barrier should be optimum, and the zeta potential should neither be positive or neither be negative, we will say. So here, one, by the addition of electrolytes we can achieve, our polymer we can achieve. Secondly, the potential energy barrier or interparticle distance we can achieve by first preparing dilute suspension. By preparing dilute suspension, we can achieve the potential energy, optimum potential energy barrier, because in dilute suspension it contains 2 to 10% weight by volume of solid particles. The solid particles far enough, they have a optimum distance between them, so that there will be no flocculation in diluted suspension. And secondly, by increasing the viscosity, of the dispersion medium, thereby preventing the movement, thereby preventing or retarding, I can say rather than preventing, by retarding the movement of the solid particles, we can prevent the sedimentation. So this is another point. So here I have explained delta A and delta G, how we can achieve. Now we will come to the gamma SL. Gamma SL means it is interfacial tension exists between solid and liquid medium. Here this gamma SL we have to make 0 so that the delta G will becomes 0. But we can't achieve gamma SL, that is interfacial tension between the solid particle and the liquid medium, to 0. Why means whatever the solid particles which is present in the suspension will have certain amount of interfacial tension. So we can't bring it to zero. So this is another one important point we have to consider. But to a certain extent we can reduce the interfacial tension by the addition of surface active agent. By the addition of surface active agent, we can reduce the interfacial tension between the solid and liquid. So the conclusion of this equation is we can't completely avoid the sedimentation of suspension in either whatever the form. Here we can take any factor. By considering any factor, we can't achieve the zero sedimentation. Sedimentation is compulsorily takes place in the suspension, as we have one of the phase as a solid and another as a liquid medium, and considerably the solid particles which is present in the suspension have 10 to 1000 micrometer in the size. So the formulator has to keep a strike between the particle size and the sedimentation, as we can't completely avoid the sedimentation. So we have to give consideration to the particles. He has to keep the balance between the particle size and sedimentation. What I am going to say is that even though sedimentation takes place, it should be redispersible easily with a little agitation. That is the conclusion of this topic. So, interfacial properties of solid.